So let's talk about some operation and some property of events. So intersection means that we try to find all the outcomes in those events. Okay, and why we want to look at the intersection later, you will see it's very common that we will try to find these things to calculate this probability, right? Because suppose we want to see the probability that a airplane fail is when, say, when all the engine fails or most of the engine fails, and it's an intersection, right? And it's like everything doesn't work, then it will fail, right? And the other common is union, right? Union will be saying if one fail, all fail, right? Or if some of them fail, then we will consider it fails, right? So there's a union, right? Something. So that's why you find all probability, all the outcomes in all the events, right? It's like finding lowest common multiple, right? And complement would be opposite case, right? Maybe we try to find the probability that this not fail, then we will figure out various way something doesn't work. So let's say example, suppose you roll a die once, then we will have the sample space is 1, 2, 3, 4, 5, 6, right? The even numbers event will be 2, 4, and 6, and the odd number event will be 1, 3, 5, and the last number will be 4, 5, and 6. So let's now do some operation on these events. So the intersection will be E and L will be looking at all the common outcomes in these two events. Okay, the common element will be 4 and 6. Okay, because 4 appear twice, 6 appear twice. Odd number and large, you can see only 5 appear twice in these two sets, so it's 5. Union is remember is getting everything there. So E and L just we try to do 4, 2, 4, 5, 6. Okay, and odd number union large will be 1, 3, 4, 5, 6. Okay, taking every one of them, and the complement will be the thing not in the event but in the sample space. So let's see. You have 2, 4, and 6. Take it out from the sample space will be 1, 3, and 5. Similarly, for large, you take out 4, 5, 6 from the sample space will be 1, 2, 3. Okay, so graphically look at the intercept will be the following, right? So 2, 4, 6 will be even, and 4, 5, 6 is even. The thing common in the middle is 4 and 6. So this is called the Venn diagram. It's very useful. The union will be include everything. So 2, 4, 6, 5, everything is there. Okay, and complement will be everything. Their sample space is 1, 2, 3, 4, 5, 6, but the even will be 2, 4, and 6. So what is the complement even will be 1, 3, 5. So next we talk about some property of events. Okay, so if two events can happen at the same time, then we call mutually exclusive, which means that this intersection is an empty set. So there's an empty set is there's no outcome that these two events are true. Okay, that will happen at the same time. And exhaustive event means the union of all those of them is the sample space. Okay, so suppose A, B union together is S, or A, B, C, D, E, F, G all together become S. Okay, and you can combine the both mutually exclusive, exhaustive. Okay, there's a very useful way commonly occur, so that's why we call partition. A partition of the sample space means you cut the sample space into different parts, which when you cut them, that means that they do not overlap, which that's why it's mutually exclusive. And exhaustive is because you cut the sample space, so it's everything add up together become the sample space. Okay, so the example would be the follow. So suppose E is even number 2, 4, 6, O is odd number 1, 3, 5, P is prime number 2, 3, 5, and B is a big even number 4 and 6. So you can immediately see odd and the big even number will be mutually exclusive because there's no common element here. All right, 1, 3, 5 and 4, 6 is the same element. Okay, and OPB together, okay, 3 of them together, is collective exhaustive because 1, 2, 3, 4, 5, 6, you can figure out, combine them together, you can get a sample space. And even an odd mutually exclusive exhaustive means there are no common element. Mutually exclusive, exhaustive is you combine them up, then will be the sample space. Okay, that is what we have for this operation of the outcomes and also the property of outcomes.